Hello, today we're looking at surface area and volume of pyramids. A pyramid is a polyhedron that has one base. Pyramids are always named according to their base. So if the base is a square, it's called a square pyramid. If the base is a pentagon, we have a pentagonal pyramid, and so on. Every pyramid has one base. All of the other sides are called lateral faces, and those lateral faces intersect at a common point called the vertex. A pyramid can be called a regular pyramid if its base is regular, meaning that all of the sides are the same. When we take a look at a pyramid, we have a normal height, which is our altitude. We also have a slant height, just like we did with cones. If you take a look at the second pyramid on the right here, you can see where they've drawn in the altitude or the height, but they've also drawn in the slant height. The slant height is if you could imagine sliding down the side of a pyramid, whereas the height is sort of like the fireman's pole from the vertex directly to the center of the pyramid. So those two things will come into play with different calculations. H is still the height, L is still our slant height. The height, the slant height, and the third side of the triangle that I've just created here form a right triangle. When we draw in this right triangle, the bottom of the triangle is half the length of the opposite side, or half the length of any side in a regular polygon. So we have our lateral and surface area formulas first. Lateral area is 1/2 perimeter of the base times the slant height. Surface area, as always, is our lateral area, so still 1/2 perimeter of the base times the slant height, plus capital B is the area of the base. And depending on the shape of the base, we'll have to use different formulas for two-dimensional area. If you take a look at question number 1, it says the roof of a birdhouse is a regular hexagonal pyramid. The base of the pyramid has sides of 4 inches and the slant height of the roof is 12 inches. If the roof is made of copper, find the amount of copper used for the roof. So first we need to know that we're calculating lateral area. When they cover the birdhouse in the copper, they're not going to put a base on it. So lateral area is 1/2 perimeter of the base times the slant height. So we have 1/2 times, if we have a regular hexagonal base, then we have 6 sides. Each of them are 4 inches. So 6 times 4, or 24, is our perimeter. And then the slant height is shown on the side here to be 12 inches. 1/2 times 6 times 4 times 12 gives us a lateral area of 144 square inches. Questions 2 and 3 ask you to find the surface area of the regular pyramid. So both of these have regular bases. Question number 2, we have a square base. It looks a little bit distorted, but it is in fact a square. It's just the angle that you're viewing the image. And we also know that's true, of course, because the directions told us that we have a regular pyramid. So our surface area is our lateral area, 1/2 perimeter of the base times the slant height, plus area of the base. When you take a look at this picture, we have the length of each side of the base as 4 feet, and of course they're all the same. We also have the normal height drawn in as 7 feet, but we're missing the slant height. So we're going to create a triangle out of our normal height, our slant height, and half the length of one base. So because this entire side of the base is 4 feet, half of that makes the bottom of this triangle 2 feet. Now we can use Pythagorean theorem to calculate the slant height. So we have 7 squared plus 2 squared equals L squared. That's 49 and 4, or 53, equals L squared. So our slant height is going to be the square root of 53. When we go back to our formula for surface area, we have 1/2 times perimeter of the base. There are 4 sides, and they are each 4 units long, so 4 times 4, times our slant height, square root 53, plus area of the base. Area of a square is just side squared, so 4 squared. When we put all of this into the calculator, our total surface area should be 74.2 square feet. In question number 3, again, we have a regular square pyramid. We have the height shown of 3 centimeters. We have our slant height, 3√2 centimeters, but we don't have the length of any side of the pyramid. So let's start by using Pythagorean theorem to find the last side of this right triangle. So we have x squared plus 3 squared equals 3√2 squared. So that x squared plus 9 equals 18, which means that x squared is 9 and x is 3. X is the length of the bottom of our triangle. If the bottom of this triangle is 3 units long, that means that every side is twice that length, so the side will be 6 units long. And since it's square, all 4 sides of the base will be 6 centimeters. Now we can find the surface area. So we can plug in 1/2 times. The base has 4 sides that are each 6 centimeters, times our slant height of 3√2, plus, to find the area of that square base, again, we're going to take the side and square it, so 6 squared. That makes the surface area for question number 3, 86.9 square centimeters. When you flip over to the back for question number 4, we're still finding the surface area of the regular pyramid. This one is a hexagonal pyramid because the base is a regular hexagon. In this picture, we have each side of the base as 6 centimeters, and we have the height of 7.5 centimeters, but we're missing our slant height. When you take a look at question number 4, if I were to connect the height and any one of the slant heights, so they're all the same, it doesn't matter which side I choose. So let's say I choose this side here. When I connect those to form the right triangle, and this is in fact a right triangle, even though it looks a bit distorted, I need to calculate my slant height. So I need to know the length of this bottom side of the right triangle. Unlike in a square or a rectangle, this is not going to be half the length of any side. You may have noticed already that this line that's the bottom of our triangle is actually an apothem for the hexagonal base. So I'm going to then draw a triangle, and this one now is lying flat on the bottom of the pyramid. So now if I connect my apothem to any vertex of the base and back over, this is the triangle that we've drawn many times inside of our regular polygons. So this is just on the base or the bottom of the pyramid, and it looks like this. So if the base of the pyramid is 6 centimeters, the bottom of this little triangle is only 3 centimeters. Remember that for regular polygons, we need to know the measure of the angle up at the top of the triangle here. That's always found by taking 360, dividing by the number of sides. And then since our triangle only takes up half of a side, we then divide that by 2. So this is a 30, 60, 90 triangle. The short leg is 3 centimeters. So the long leg, which is our apothem, is going to be 3√3 centimeters. Okay, once we know that long leg is 3√3, or the apothem is 3√3, now I'm going to go back to the dark blue triangle and use Pythagorean theorem to find the slant height. So now I have 7.5 squared plus 3√3 squared equals the slant height squared. That's 83.25 equals L squared, or a slant height of about 9.1. Okay, now we have all the parts we need in order to calculate the surface area. So our surface area, 1/2 perimeter of the base times the slant height plus area of the base. So we have 1/2 times the hexagonal base has 6 sides that are each 6 centimeters. Our slant height we just calculated to be 9.1. And to find the area of the base, remember area of a regular polygon is 1/2 perimeter times apothem. So this is plus 1/2. Perimeter is again 6 times 6. And our apothem we said was 3√3. Okay, when you've put the first half into your calculator, the lateral area is about 163.8. Area of the base, the second half, is 93.5. And together they make a total surface area of about 257.3 square centimeters. And then our last formula for today is the volume for a pyramid. Volume for a pyramid is 1/3 area of the base times the height. So this is now the normal height perpendicular to the base. In questions 5 and 6, we're asked to find the volume of a pyramid from a previous question. So for question number 5, we need to go back and look at the pyramid from question number 3. So we need the area of the base and the height of the pyramid. So if I go back and look at question number 3, we've already calculated the area of the base. The base was a square, each side was 6 units, so area of the base was 36. We also need the height of the pyramid. Height is perpendicular to the base. That's the fireman's pole from the vertex down to the bottom. And in this picture, that's 3 centimeters. So to find the volume, I'm going to multiply 1/3 times 6 squared times 3. And the volume of this pyramid is 36. That was in centimeters. And for volume, it should always be cubed. So 36 cubic centimeters. In number 6, we want the volume of the pyramid from question number 4. So again, we need to know area of the base and the height of the pyramid. So we have 1/3 area of the base. We already calculated here. That was the 1/2 perimeter times apothem for the regular hexagon. So that was 93.5. Times the height of the pyramid which is drawn in here as 7.5 centimeters. So the volume of this pyramid ends up being 233.8, and this is also cubic centimeters. And for the last question, it says find the volume of the solid below. When you take a look at this picture, imagine a solid block of ice that they cut out a pyramid shape from the top of the block. In order to find the volume of the space that's left, we're going to first find the volume of the solid block. So we're going to find the volume of the full prism and then cut out or subtract off the volume of the pyramid. Volume for a prism has the formula area of the base times the height. In this prism, let's say the base for this square prism is 6 by 6 centimeters. So area of the base, 6 times 6, times the height of the prism, 4 centimeters. So the prism has an area of 144. For the pyramid, volume we now know is 1/3 area of the base times the height. When we take a look at the pyramid, its base is a square. So to find its area, we're looking at 4 times 4 times the height of the pyramid is the same as the height of our prism. So that's going to be 4 as well. 1/3 times 4 times 4 times 4 is 21.3. So when we cut out that pyramid from the prism or subtract its volume off, we get a volume for the solid of 122.7 cubic centimeters. As always, have a wonderful day. Please let me know if you have any questions. Make sure you do the homework, and I'll be back tomorrow.